Welcome. Thanks for being here. Let's have a show of hands. How many of you wish that you spent more on storage than you do today? I see no hands going up. Congratulations, you're in the right room. The topic we're talking about today, me and my colleague Eric here, is guidelines and design patterns for optimizing cost on Amazon S3. So let's get started. We have a long agenda here, more topics to discuss in less time. I'll start with an overview of Amazon S3. I'll cover some pillars of cost optimization, which is more around how we view cost optimization on Amazon S3. I'll get into some storage classes and in-depth details, because in our opinion, understanding the right storage class for you and picking the right one can make all the difference. And then my colleague here, Eric, will get into some cost optimization guidelines and design patterns. And then we lied there. There isn't a customer Pinterest, but we will give you customer examples, which is just not Pinterest. And then we'll summarize it. Now, before I get started, the one thing I'd like you all to take away from this talk today is at least one best practice or design pattern that you think is going to help your specific use case. And if that happens for all of you, Eric and I will consider our evening successful. AWS has helped customers for the last 13 years build on AWS. We've had customers like Netflix build ground up on AWS. We've had customers like General Electric, on the other hand, transition more than 9,000 applications from on-premises to the cloud. And as a result of this customer input and listening to you guys over the last 13 years, we guide more than 90 to 95% of what we build based on what we hear from you. And so we have a very broad and deep portfolio of storage services. So you can see file, block, and object store here. In this session, we're only going to talk about object store and how you can optimize cost on it. Amazon S3 is AWS's object store, as a lot of you would know. And the one thing I can say confidently about S3 is that today, almost all industries and all use cases that they have exist in some form on S3. And the reason for that is primarily because we offer industry-leading scalability, security, performance, and durability. And just to give you a few examples, we have exabytes of data stored across millions of drives. We have trillions of objects across the world today. We regularly peak at millions of requests per second. And in a single region, we process over 60 Tbps in a day. Now, S3 is on one hand, and then we're talking about cost optimization. This is just a framework we look at today. We look at cost optimization in the form of 4 pillars. The first one is application requirements. Now, if you look at the room today and look at the person sitting next to you, I can guarantee that their application requirements are different from yours. And understanding what your specific requirements are is key to optimizing cost. And you're the best person to understand what these requirements are. I'll get into more details on each of these pillars, but that's the first one. The second is data organization. At the very start, when you're building your applications, you want to think about the right organizational techniques. You want to then right-size it. When I say right size, I mean choose the right storage class, set up the right policies, make sure you're putting the right sets of data that you've organized in the right storage class. The final pillar here is about, once you've done these 3, you want to monitor, analyze, and recheck those assumptions. Have you figured out the right application requirements? Did you put all the data in the right places? And if not, you want to go back to this process and repeat it. So it's not a one-time process. It's a continuous step. And we'll get into all of these. Let's start with the first one, application requirements. These are just a few of the use cases, but let's pick a few. Let's say you have a dynamic website you're building, which means that you have very random access patterns. You want high availability, high throughput, and high durability of your data. Let's say on the other end, you're doing some analytics. You do have frequent access of that data, but you may not be as concerned about availability. Finally, let's say you have backups. All you care about in that situation is, I want to store my data in a second region. It might not be accessed very frequently. What do I do about optimizing cost for such situations? So these are some of the parameters you want to consider about your application. What is the redundancy you're looking for? What kind of availability suits your application? What kind of performance? Do you want millisecond latency, or do you want minutes or hours? What kind of size of objects are you storing? And how long are you storing that data for? Once you've figured all of that out, you want to organize it in the right way. So the first step is putting your data in buckets based on, which is an S3 resource, based on what is the data, what accounts are being managed with it, and what teams are accessing it. Now, while S3 is a flat structure, to make it organizationally simple for you, we have the concept of a prefix, which is a name in front of your object name that can be thought of as a folder. That helps you organize data. On top of it, we have something called object tags, which are key name pairs that you can attach to each object. You can have up to 10 object tags in an object. Based on prefix and object tags, you can then do a whole bunch of things. You can write policies to transition data, to expire, delete data. You can monitor what is the storage based on a prefix and an object. You can do a bunch of things just by organizing it in the right way. I was talking to a customer recently that is a research company, and what they do is they have test accounts and production accounts, and they have all this data in one single bucket, but after they do this analysis on the test account, after 4 weeks, they don't really need that data, but you're storing there anyway. So what this customer did is something very similar to what's shown here. If you look at the last piece there that says environment test, it's an object tag they created. And tagged each of their objects as either environment equals production or environment equals test. On top of it, they wrote a lifecycle policy that says anything that is tagged with environment equal test should be deleted after 4 weeks of creation. Now that means that they're no longer paying for the data that was test data that they've processed, analyzed, and no longer need after 4 weeks. So that's one way of optimizing cost. We recommend that you organize your data right from the beginning to make it easier to optimize cost from day one. You can go back and reorganize your data, but based on what we've seen talking to customers, it just grows and grows, and your data is growing, and this will be difficult to do later. Now, you're deciding on organizing your data, and while you're doing that, you also want to figure out what is the right format you're ingesting your data in. Now, there's no one right answer to this. On one hand, you have unstructured formats like JSON and CSV, which are easy to parse through, but may be slightly less efficient. On the other hand, you have Parquet or ORC, which have an inherent compression built in. They offer better query performance and hence reduce cost for you. So the best practice we advise customers here is to use efficient data formats if your use case allows that. That's the next thing you want to consider. Coming back to the third pillar we talked about, which is finding the right storage class that fits you. And the one thing that's important here is picking the right storage class can help you save costs up to 95%. And that's why the second section, what I'll talk about here, is a lot more detail into storage classes. But here's an outline of what is the flavors we offer. So let's say you're looking at redundancy. You want to build for multiple regional redundancy, and you want to put your data in 2 regions. Or you may want to just put all your data in 1 region and have a 3 availability zone model. Or you may have recreatable data, and you don't really care about data loss, and you can choose to put data in 1 availability zone. In all of these 6 parameters, as you go from left to right, you're reducing cost. So these are the trade-offs you're making when picking the storage class based on what do you need. The next one here is availability. We offer storage classes from 99.99% availability all the way to 99.5% availability. We have storage classes that are frequent access, infrequent access, all the way down to an archive storage class, or 2 of them, I should say. We have performance, object size, and duration. I won't get into all of them, but these are all trade-offs that you want to think about when you're picking your storage class. Now, before I get there, a lot of the times when I talk to customers and I show them this slide and ask them, what is the trade-off you're making? What is it that your application requires? The one thing that comes up is that I'm fine dealing with all these trade-offs, but I don't want to trade off durability. And the thing about all of S3's storage classes is that we offer 11 nines of durability across the board. So let's get into that for a little bit. We have 22 regions across the globe with 69 availability zones. We have announced plans for 13 new availability zones and 4 more regions in Indonesia, Italy, South Africa, and Spain. And we don't plan to stop there. Talking about an AWS region, it's made of a cluster of data centers spread across that region. Each logical combination of data center is called an availability zone. And we architect our regions to have data across multiple availability zones. In a lot of the cases, AWS can sustain the loss of an entire availability zone and still give you high availability and durability for your data. And this is across the board, as I said. The final pillar I talked about is to monitor, analyze, optimize, and manage your storage class. The first one, monitoring your storage class. We have a tool called Amazon S3 Inventory. What this does is it gives you a report of lists of objects in your bucket, and it lets you audit and report on, say, what's the replication status of these objects, or what is the encryption status of these objects. So you can use it for a bunch of business and compliance purposes. The second one here is a feature called S3 Storage Class Analysis. What this does is it monitors and analyzes your access patterns and gives you recommendations at the end of it. So let's say you have 1 million objects in your bucket. You run storage class analysis on it, and it shows you that 80% of your data is not really being accessed a lot. But you have all this data in S3 standard, which is a frequent access storage class, which means you're paying a lot for storage, but you're not really accessing this data. So it might make sense to move that data to an infrequently accessed storage class. So that's another tool you have. Then we have something called batch operations, which is the third thing here. Batch operations lets you perform large-scale operations like copying data from one location to the other, from one storage class to the other, like adding tags. Let's say you just realized your data is not organized in the right way, and you're not able to set up lifecycle or replication policies on it. Using batch operations to add object tags to them and then set up these configurations will help you save costs. The final one here is we offer tools to automatically tier your data. If you don't want to invest time and effort in figuring out whether this is frequently accessed data or infrequently accessed data, we have a storage class called intelligent tiering. I've talked about lifecycle a bunch of times, which basically lets you either tier storage from, let's say, move it from hot storage to cold, standard to infrequent access after a given period of time, or even delete the data, as I mentioned in the example of a research company. So let's dive a little bit deeper into storage class, because understanding what is the right storage class to use, as I said before, can help you save 95% in costs. Before I dive into that, I want to talk about how in S3 we think about pricing, and we think about pricing principles. And it's not just S3, it's AWS at large that follows these pricing principles across the board. So the first one is we have no upfront costs. You pay as you go, which means you never over-provision or under-provision for storage. So you're saving cost. You have no upfront investment, which means you can innovate faster. The third one here is as you use more and more of S3, we have inbuilt volume discounts. So the more you use, the cheaper per object or per gigabyte unit it costs you to store in S3. And finally, as AWS grows and as S3 grows, we take all this feedback from you guys and invest in innovation. And that innovation translates to more ideal features and use cases for you that help you further reduce your cost. This is just a snapshot of what has happened since we launched S3. The left side here talks about since the launch in 2016, over the last 13 years, we've reduced storage prices by more than 80%, which means that without doing anything at all, you're saving 15% in cost year over year, without touching your storage at all, if you were storing the same amount of data. The graph on the right talks about how we've accelerated our innovation and given you more and more options as we went along. So we launched S3 Standard in 2006. Then we launched S3 Glacier for archival data in 2012. We then launched S3 Standard IA, which is a storage class for infrequently accessed data, in 2015. Then in 2018, we launched OneZone IA, which is meant for infrequently accessed data that is recreatable. So we store it in only one availability zone as opposed to 3 in other regions. In 2018, we came up with intelligent tiering and deep archive. And these two are really the most popular, or I would say our customers love these two storage classes the most today. And I will get a lot more detailed into those two at the end. But let's look at all of them. So let's say you have data that is frequently accessed, it's active, and you know that you may delete it in 30 days or less. We recommend you use S3 Standard. It offers very low, millisecond latency. It offers high performance, a high availability, and it's the best storage class for such data. Let's say you have data that is not accessed so frequently. You might store it for more than 30 days. You can use S3 infrequent access, which offers you a 40% lower price point than S3 Standard, but you pay a small retrieval fee when you actually access these objects. So it's really meant for data that is not accessed as frequently. Moving on to the same one, let's say you have infrequently accessed data, but you don't really care about durability as much. Cost is an even more important factor for you. And this is data you can recreate easily. We recommend you move to OneZone IA, which further reduces cost as compared to SIA, S3 infrequent access, by further 20%. Let's say you have archival data. We have a storage class for you, which is S3 Glacier, meant for all kinds of archival data. I'm not going to get into the properties of these storage classes. And they, like I mentioned before, they all offer the 11 nines of durability. S3 Glacier is further 60% cheaper than OneZone IA. So you can see how this cost is massively going down as we're going there. And then intelligent tiering, which is a recently launched in 2018 storage class, it's meant for data where you don't understand or don't want to invest time in knowing your access patterns. So what intelligent tiering does is it prices your storage dynamically between a frequent access and an infrequent access tier based on how you're using it. So with intelligent tiering, we monitor your access patterns, and we price it dynamically. And then finally, we have Glacier Deep Archive for long-term archival data. This is something that we launched in 2019. It's been another really popular storage class with our customers. So let's dive or double-click a bit on intelligent tiering and deep archive. Intelligent tiering, as I said, automatically tiers your data between a frequent and an infrequent storage class. It monitors your data for a minimum of 30 days and then does this tiering for you automatically. There is no performance impact when you use this. There is no operational overhead, and there is no retrieval fee. If you were to store a lot of your data in infrequent access, and then all of a sudden, some user in your organization were to access it, you'd end up paying those retrieval fees. With intelligent tiering, you get rid of even those. So let's look at what are the use cases you might want to use this storage for. The first one is data lakes. A lot of our customers are storing massive amounts of data in one S3 bucket and that data is being used by multiple teams across the board. Often, there are hundreds of applications that are accessing this one single bucket. It's possible that you don't really know what the access patterns of these hundreds of applications are, so you can't predict what the access pattern of an entire bucket is. Even if you do understand what the access patterns of those hundreds of applications using the same bucket are, it is really difficult to then combine all those access patterns and decide what is the best storage class for your bucket. And so in that case, you want to leave that heavy lifting and that intelligent tiering to Amazon S3 and use S3 int. The next one is big data analytics. We have a customer called Climate, a subsidiary of Bear. They use intelligent tiering, and what they do is they deal with farmers, and they do geospatial analytics based on land images for a lot of farmers across the world. Now, they run multiple applications and multiple use cases across the globe. They don't really know when which scientists are going to access data from their buckets. And so they use intelligent tiering, and they've been saving costs because of this unpredictable pattern of data access. The final use case here is the long tail of customers. When I say long tail, I mean customers who are constrained on resources and don't want to invest in figuring out what the access patterns are. Let's say you're paying a total of $100K a year on S3. It's such a small amount that you don't want to hire someone to figure out what your access patterns are and then choose the right storage class for you and do all this monitoring. So again, you can leave it to S3 intelligent tiering and let S3 do that analysis for you. The last storage class I'll talk about here in a bit detail, is Glacier Deep Archive. Glacier Deep Archive is the lowest cloud storage class available out there. It's something that we heard a lot of feedback from customers and came up with this year. A lot of customers told us that they don't really want to manage tape. It's expensive. It's very operationally expensive. You have to constantly worry about things like power failures, damages, degradation to your tapes. You have to worry about things like retrieving it every time you have an off-premises tape that you're storing your archival data on and you need that object. You have to go find someone who goes to that offsite, gets that data for you. You can't do things like machine learning on the data that is stored on that tape. All of these and more were reasons we came up with Glacier Deep Archive. It gives you the same durability that you've come to expect of all the storage classes in S3. It recovers data in 12 to 48 hours, as opposed to weeks that it might take you if you're storing something on an off-premises tape. Finally, it gives you the same performance as S3 Glacier with a much, much lower price point. It costs you 1/10 of a cent to store data in Glacier Deep Archive per gigabyte month, which translates to $1 per terabyte per month. And you can't really go lower than that. So these are the use cases that you might want to use Glacier Deep Archive for. We have a lot of financial services and healthcare customers, and they have things like financial records or health records that they're required by compliance to store for long durations, 20 years or even 50 years occasionally. They're storing this data, but they're not really analyzing it or accessing it or even reading it for years and years. In that case, Glacier Deep Archive is a great use case for you. The next one is data retention. A lot of our customers running workloads like machine learning have raw data that they use, analyze, and then they want to keep it. They don't want to throw that data away because maybe a few years down the line, you want to retrain some ML models and you want to come back to that data and use it again. Glacier Deep Archive is a great use case for that. We also have security companies that have, let's say, raw camera footage that they don't want to delete altogether. That's another good use case for it. Finally, a lot of our customers set up disaster recovery on S3, and they use cross-region replication to create another copy of data from one AWS region to the next. Now, the second copy that you're storing in the second region is just for a disaster situation. You're not accessing it frequently. So using Glacier Deep Archive or even Glacier as that second storage class can reduce costs a lot for you. So that's mostly about all the storage classes. I'll pass it on to Eric from here to talk about some guidelines.
Thank you. Hi, I'm Eric. I'm a principal product manager on the S3 Glacier team. And as Rui said, I'm going to spend a little bit of time talking about some strategies that you can employ to take advantage of these different storage classes, as well as some of the features inside of S3 to optimize for cost. So to start with, and with optimizing with cost, across any number of AWS services, including S3, there are tools available to you to monitor, well, to first plan how much you intend to be spending on your storage, and then to monitor that spend in order to make sure that you're keeping that budget in line with your plans. The first of those tools is AWS Budgets. So AWS Budgets gives the ability for you to set custom budgets with thresholds that you could define around your planned costs. That will then, if you exceed those planned thresholds, it will alert you that your bucket is, your costs associated with your bucket is exceeding what you were forecasting. It will also let you know if you're not meeting, say, a minimum threshold that you planned for that bucket. And why that's important in terms of cost optimization is it allows you to turn around and reevaluate what is the business need, why has it changed, why is our storage usage lower than I planned, and then reforecast those budgets. The second one is the use of Amazon CloudWatch. So CloudWatch will allow you to set real-time metrics around two parameters. The first is a daily S3 storage usage. And so that usage can be defined both as the number of objects in a bucket, so you can set a threshold around that number, and also around the total amount of data stored in that bucket, and set a threshold around that. And then also a minutely request activity. So if you're seeing an inordinate amount of requests and there are fees associated with those requests, you can also receive CloudWatch alerts when your spend is not occurring as expected. So after you've set up your budget plans and are monitoring that to ensure you keep in line, you then need to look at the broader picture of what are your business requirements. And so one of the things that can really affect your spend associated with storage is data protection. And data protection is a requirement for virtually every business out there, but there is a cost associated with it. So having a thoughtful plan and using the right storage classes as well as the storage S3 features can really help you keep those costs under control while still meeting your business objectives for having a disaster recovery plan, meeting your backup and recovery requirements, and meeting any data retention requirements you might have. So looking at backup and recovery, you need to understand sort of what does that access pattern look like for your backups. So how often what are your critical data sets? How often do you need to back up those data sets? And then where do you see most of your restores coming from? Because that'll allow you to make decisions, say, if most of my restores are coming out of the first 30 days, then I can use a more active storage class, say like S3 Standard or S3 Infrequent Access for the first 30 days of that backup set. But then if I typically see any sort of restore requests fall off after that, I might have a requirement to store my backup data, say, for 7 years, as a lot of enterprises do. But I might choose after 30 days to, say, have that data be lifecycled off to S3 Glacier, where I see fewer restore requests, and I can take a bit longer to bring back that data, say bring it back in typically hours or minutes if needed, and then ultimately, say, after 90 days, have that moved off to Glacier Deep Archive, where then I'm really keeping that data just in case, but might occasionally need to go back, say, once a year and retrieve some data out of that data set. The other piece to consider is data retention. So you might fall in an industry where you have data retention requirements to retain data over the long term. So it could be healthcare data, patient records data. It could be financial records. It can be things that fall under legal hold. So we have tools that you can take advantage of, not only to cost effectively store that data in things like Glacier and Glacier Deep Archive over the long term, but you can take advantage of features like S3 Object Lock, where you can set a policy that makes that data immutable, so it cannot be deleted by by anyone other than you, the administrator, or in the case that you fall under, say, financial regulations, that it can be immutable by even anyone. And those features come to you, the features like Object Lock come to you at no cost, It's just something you can set as a policy on your data when it's being stored in any of our storage classes. And then finally, disaster recovery. So disaster recovery, in my experience, is a requirement for every business, but maybe isn't fully implemented in every business due to the cost associated with it. And so a very interesting pattern that we've seen since we launched Glacier Deep Archive is the use of, and Rudy alluded to this, is the use of cross-region replication to say where you might have your primary data set in one region in S3 standard, to have that data stored, say, in Glacier Deep Archive, replicated, a copy of that data replicated in Glacier Deep Archive in a secondary region, giving you a very low-cost disaster recovery plan for your data. But in order to make decisions like that, you need to first understand what are your recovery point objectives. So that meaning how much data loss can your business withstand? How often do you need to be replicating that data? Do you need to put an SLA around that? And then recovery time objective, putting it in a storage class that will allow you to meet your recovery time objectives means how quickly can the business be without that data. So do I need to get back to that data within milliseconds to seconds, and do I need to put it in S3 standard with a secondary copy, doubling my storage costs? Or can I store it in in a asynchronous storage class where I can wait for the retrieval time, say in Glacier, whether that's minutes, hours, or days? All of those are levers you can pull to optimize for cost. And then the other consideration is, for disaster recovery, do I require geographic redundancy? Do I meet a requirement replicating my data in the same AWS region, perhaps just in a secondary bucket? And is the durability model of our being of S3 being a region-level service and having that data redundant across multiple data centers enough, or do I need to have that at an entirely separate region for geographic redundancy? So in regards to data protection and sort of the idea of backup, S3 has a native feature called versioning. And so what versioning enables you to do is to potentially meet that data protection requirement or that backup requirement by every time you create a new version of an object and you upload that new version to a bucket, then a version of the original object is then stored. So you'll have the new primary version, and then you'll have a secondary version that you can roll back to. It's also there in the event that, say, an object is accidentally deleted or there's some malicious activity. You can always go back to the previous version and access that and bring it back within milliseconds. And every time a new version is uploaded, then another copy is created, so version 1, version 2. So this can be a great feature to automatically protect those objects in your most critical data sets. The challenge is that in the consideration around cost that you want to think about is with versioning enabled on that bucket, then every time, or that prefix, every time I'm uploading a new object, a new version of that object, I'm creating another copy of that data and I'm increasing my cost just that much, right, linearly. So what you need to do is then be very thoughtful about where you're implementing versioning, but you also need to be really thoughtful about how you're managing those additional copies. So say I know that I really only need to keep it for a matter of days, then I can do things like I can set a lifecycle policy to either automatically expire those secondary versions after a few days, or if I maybe don't need millisecond access to those versions, I can lifecycle those versions off to, say, Glacier or Glacier Deep Archive to store them in a more cost-effective storage class and then set them to delete at a later time. The other feature that can help you meet both your data protection and your disaster recovery objectives is much what the example I already referenced, is using cross-region replication, or using S3 replication to create a redundant copy of your data. And so there's a few different options now with S3 replication. We've actually been doing a lot of work on this in the past year. So from the beginning, we've had S3 cross-region replication. So what that does is it is an asynchronous service that once I implement it on a bucket, every time an object is uploaded into that bucket, it is asynchronously replicated to a corresponding bucket in a different region. That maintains all the original metadata with that object. It retains the original date and timestamp. What I can do, a few things, like I can change the access policies to those buckets to protect that secondary copy. I can have it be on a different account, all of those things. So that's been there for some time. And that, while that was good enough for many customers, we had many customers coming back to us with a few different requirements. One was, I don't need actually to create a replicated copy of my bucket in a different region. I actually just want to have it in the same region. But I wanted to have the original date and timestamp and all the associated metadata. And I might use that for a data protection, for a disaster recovery copy, or I might use that, say, for a test and dev copy. So that's why earlier this year, we launched S3 same region replication. So virtually the same feature set as cross-region replication, just allows you to do it within the same region. The other piece is that, as I mentioned, object lock. What we've seen with a lot of customers for compliance requirements, or just really even as a security requirement to ensure that that secondary copy of their data is immutable, is they're using S3 object lock with cross-region replication or with same region replication so that they can keep an immutable second copy of their data, safely locked away that cannot be accidentally deleted or maliciously attacked or deleted. And then most recently, just last week, we had heard from a number of enterprise customers is that, hey, I have to have an SLA back to my business about the window and time in which this data is replicated. So with the original cross-region replication, most of your data would be replicated within the day, but there wasn't an SLA around it, and there was a matter that it was potential that it could take longer. With Amazon S3 replication with time control, what that does is it's an SLA of 15 minutes that it's been designed that for 99.99% of your objects will be replicated to the other region within 15 minutes. The SLA is for 99.9% of those objects to be replicated within 15 minutes from any region to another region. And so there's different cost levers for these things, but again, depending on the requirements that you're trying to accomplish for your disaster recovery strategy, you can optimize for that. The other piece, which I want to just hammer again, is it's really important to remember that with S3 replication, that you can replicate from any storage class, any synchronous storage class, to another synchronous or asynchronous storage class. So I can go from S3 standard to infrequent access, S3 infrequent access, to Glacier or Glacier Deep Archive. But so you can really have to think about what is the access pattern of that second copy and how do I most cost effectively store it. So another consideration is really understanding the access pattern of your data, and you've heard us say that a lot. And so it's really incumbent, and we sort of see three high-level access patterns generalized across workloads. And these workloads might be storing machine learning data, it might be a big data analytics model, it might be a data lake, it might be backups. All of these are going to have different access patterns. So it's really, you have to be thoughtful about how you're implementing your application so that you can take advantage of the right combination of storage classes, right? Because it's typically not a one-size-fits-all thing. There's probably some different storage classes. And to remind you that you can store objects, storage classes are defined on a per object level. So you can have storage objects of different storage classes within the same S3 bucket. So this allows you a great deal of flexibility for managing cost. So the first is the frequent access pattern. So this is a case in which more than 100% of my data stored is retrieved in that given month, right? So this is data I'm regularly writing to. It's frequent access. It might be big data analytics. It might be a dynamic website. It might be IoT sensor data. And so in this case, the best storage class for you in the vast majority of cases is S3 standard. It's sort of what it was built for, particularly like in the case of IoT sensor data where you have lots and lots and lots of very small objects being constantly written and maybe not long-lived. Or data lakes where you might be staging your ingest layer and you're having lots of data that later is going to be transformed, you want to put that in S3 standard. But that doesn't mean you leave it there over the long term. S3 intelligent tiering may also be a fit for this, with the exception of, and I'll mention this in a bit later, but you want to have some consideration around the number of small objects you might have. The next is the infrequent access storage pattern. And so in the infrequent access storage pattern, this is when less than 100% of my data is retrieved per month. Now, how much less is going to make some decisions around what storage class makes sense for that workload, or at least that part of the workload. Eventually, I mean, the sort of obvious thing that we've seen here is that typically once data is written, it tends to cool off over time, right? In the vast majority of workloads. So particularly with logs, with user-generated content, content delivered from sync and share applications or applications that are on your mobile that are accessed on a mobile device from many different users. The data cools off fairly quickly in those cases. And so there you typically want to use some sort of combination of your storage classes. So that might be S3 standard, and then leveraging a lifecycle policy to move that down to infrequent access. It might be S3 intelligent tiering and just let us do that for you, right? Get automated cost savings. And then ultimately, at some point, depending on the value of that data, you likely want to move that off to Glacier or Glacier Deep Archive. And I'll talk a bit about sort of how to think through exactly what that policy should look like. The final one is the changing access pattern. And the best example is data lakes. It's a prominent use case we see on S3. And it's one of the main reasons we really developed the S3 intelligent tiering. And this is because you have changing and unpredictable access patterns. You have data coming from many different sources, many different agents writing into that data lake, and not just many different agents writing into that data lake, many different applications accessing that data lake, and perhaps even users doing ad hoc queries against that data. So something might go cold, it seems cold for some time, suddenly that data becomes active again, and it's very difficult to plan around. So intelligent tiering allows you to have that data sort of fluctuate between the frequent and the infrequent access tier without a penalty around the retrieval fees when you can't predict that access pattern. So that can help you with cost quite a bit. So as I said kind of during the last slide, you really need to know your access pattern. And in talking with customers over the years, we sort of begged this question often and said, well, but I don't know my access pattern. How do I find this out? So there's a couple strategies for how you go about doing this. So the first option is sort of the building block approach with S3 native features. So first, you can store your data in S3 standard. Let's say it's a new workload. Start with S3 standard, store your data in there 30 to 45 days, and turn on storage class analysis. Ruby mentioned this earlier. Storage class analysis is a tool that will run across your bucket, and it will monitor the access patterns of the objects in that bucket, and then give you a report and to let you know whether how frequently the objects are being accessed, so that you can intelligently configure lifecycle policies with data. And so turn on storage class analysis, let it run 30 to 45 days on that bucket, and then accordingly develop a lifecycle policy. And you can do that in various combinations. So it could be a fairly complex lifecycle policy that I have an example on the next slide that tiers across various storage classes. The other option is take advantage of S3 intelligent tiering. So allow us to automatically optimize for cost for you between the frequent and the infrequent access tier. But you still likely want to know how much frequent data do I have, how much infrequent data do I have, and you'll see the cost savings on your bill. But you can go and find this out by turning on CloudWatch metrics that will allow you to show bytes by access tier. So how much data do I have being stored in the frequent access tier? How much data do I have being stored in the infrequent access tier? And then most recently, earlier this year, we added reporting on the S3 inventory reports. So you can get an S3 inventory report once a day that will give you a listing of all your objects in that bucket and will let you know which tier inside of intelligent tiering is that object being stored. Is it in the frequent access tier or is it in the infrequent access tier? So we've talked a lot about lifecycle, so let's give an example of what policy might look like here in implementing these strategies. So I could do what I said. I could have stored my data in S3 standard, and I've run storage class analysis for 30 to 45 days. Now I want to build a policy, or I did an intelligent tiering, and I went the other route, and I pulled inventory reports to understand what that access pattern looks like. I'd like to get my data into Glacier because it's valuable data, and I really want to take advantage of those cost savings. So now I've learned that data. I've learned that access pattern by those reports. I can now set up a lifecycle policy that, say, for example, I went the S3 intelligent tiering route. Then after 180 days, I know my data really cools off. There's a very little chance that I might need to access it, but in the event that I do, I still want to have the option to get it back in minutes if I need to. So after 180 days, I have the objects in that bucket tiered down to the S3 Glacier storage class. And then I have a retention policy, let's say, of 7 years. But I know data gets significantly cooler after a year. So after 365 days, I move those objects into Glacier Deep Archive. And then, say, after 7 years, I have a lifecycle policy that just sets to expire all of those objects, just automatically deletes them. And I meet my data retention requirements, automated it, and I'm implemented cost savings. So we touched on batch operations earlier. So this is a great tool that you can take advantage of that will help you manage and implement some of these policies on massive data sets. So you might have millions or billions of objects, and you want to, say, implement a lifecycle policy around them. And so I've pulled the S3 inventory report. I've got a listing of all my objects. I can use batch operations to query that inventory report, or I could create my own CSV file to do this as well. And then let's say, in this case, I want to change tags on a large set of those objects. So say 1 million of those objects, and I want to change a tag because I'm going to implement a lifecycle policy that is specific, that is driven by a tag. So any object with this particular tag then will be fall under this lifecycle policy. So I select that up. I've selected my objects, my grouping of objects. I select my operation, which is changing this tag. And then I simply just execute the few clicks. I implement the batch operations policy in the console. I get a progress update. That's completed. I've now implemented my lifecycle policy. And I've been able to do this fairly easily in minutes. So another key consideration is really the characteristics of your data set. And there's sort of 2 key characteristics you want to think about. One is going to be the number of objects that you have, and then what is the size of those objects, and then what does that distribution look like? So, for example, does my bucket, is it primarily large objects, right? Is it, say, objects that are in excess of 50 megabytes? Are they media files? Or is my bucket full of very, very small objects? In fact, most of my objects are measured in the 1 to 2K range. So I need to know and understand this distribution because that's going to allow me to make cost-effective decisions around which storage classes I can take advantage of, and also not shoot myself in the foot, let's say configuring a lifecycle policy that might actually increase my costs. So let's use the small object example because it's an easy one to pick on. And let's say I have small objects, and I actually, with my application, I can't really control the size of my objects. Let's say it's coming in from IoT sensors, something like that, into my staging area. So by knowing that I have, say, billions of these small objects, I know I want to do something first around the object size before I, say, implement them, try to move them to S3 and frequent access. Because S3 and frequent access has a minimum object size of 128K. So I would be implementing a bad policy, trying to save costs by moving my objects there as they're not eligible for that storage tier. Or for instance, let's say I tried to lifecycle them to Glacier. Well, in most use cases, lifecycle costs are a fairly minimal one-time charge that are more than outweighed by the amount of savings I have by much lower storage costs over time, but not in the example I gave. If I had millions of very small objects, well, Glacier has a 40K minimum object size. I'm under that object size, so now I'm going to have to pay the difference because they're going to be treated as a 40K object. And let's say I had millions of these objects, I've suddenly run a very large lifecycle transition. So what I'd want to do is to look at ways where I could control the size of my objects. So let's say if I'm moving them to an archive, then maybe I want to create tarballs of those files. Or in a data lake use case, maybe I want to do some ETL processes where I can actually create a fairly favorable object size that works well. We see sort of ideal, like in those latter use cases, is objects between 5 and 50 megabytes tend to be ideal object sizes where you can get a good cost-benefit analysis for taking advantage of all those storage classes. The other piece is performance requirements, and this session isn't on performance, but there are several others, so I'll share those in a minute. But so 2 pieces you really want to think about is my workload a synchronous workload, or is it an asynchronous workload? So again, why that's important, it's a decision tree of to which storage class can I take advantage of. So in a synchronous workload, so synchronous storage classes, just so we're all thinking the same thing, that's S3 standard, that's infrequent access, that's infrequent access 1 zone, that's intelligent tiering. All of those are synchronous storage classes, meaning I put my data, I can immediately turn around and get my data. It also is important to realize that while all of those storage classes that I just listed have different cost dimensions, the trade-offs based on the frequency of your access, as we were just discussing, they have identical performance. So for you to think about it is really think about them as different economic models in how I'm consuming and accessing my storage. But what you do have is you have the exact same performance, and with the exception of 1 zone IA, which is 11 nines of durability in a single AZ, they all have the exact same durability model, 11 nines of durability across all AZs. So it's really just access pattern, and is it a synchronous workload, access pattern, and then how do I maximize my savings? What's different is the Glacier storage classes, so S3 Glacier and S3 Glacier Deep Archive are asynchronous storage classes. So what that means is I put my data, or I lifecycle my data, and then I want to get my data, I have to restore my data, so that a temporary copy of my data is restored. My object still lives in Glacier, but a temporary copy is restored that I can then access for a specified duration, and then I can get that temporary copy. So your application has to be able to handle that logic, or you have to build that logic into your workflow. But there's significant cost savings in doing so, assuming it meets your access pattern requirements. And the other piece in there, which I already mentioned, is really to think about with the asynchronous ones in particular is really optimized for object size before you take advantage. It's, again, tremendous cost savings, but you want to be thoughtful about that. And there are, I'm not sure which ones have run yet, I apologize, but there are 3 sessions that some colleagues of ours are running on performance this week as well. If you want to go check those out, they'll get much deeper on that. So we've talked quite a bit about the storage classes themselves. The point I want you to take home from this is that it's not a one-size-fit-all. In your workload, it's likely some combination of storage classes. And so we might see, a lot of times customers building a net new application, they start with S3 standard and then they sort of forget about it and just continue moving on with S3 standard. And then, later say, man, my costs are spiraling out of control. I really need to get a handle on that. So really think about these things that I was talking about here up front about, the access pattern and synchronous requirements, all of that. But while making those decisions when you're designing what your application is going to look like, and take advantage of all the appropriate storage classes. A good example of this is, again, one of the most popular workloads we see on S3, which is data lakes. And so in this example, this is a great example of how to use different storage classes in the entire same workload. So in a data lake, you have all of this data coming in, all this raw data being ingested from all over the place. You have log files, things being overwritten, lots of data churn, short-lived. It might be censored data. It might be being deleted. It might be being batched, archived. It's just lots of data movement here. Definitely stays in S3 standard, right? This is not going to be very long-lived here. And while it's relatively the highest cost storage class, this is a short-lived data set. And then when you take advantage of extract, transform, and load process, and ETL process to transform that data, also in S3 standard because of the churn associated with that process, say if you're using AWS Glue to do that. But what you can do, like with Glue, is during that ETL process is that you can optimize for your data set, right? You're formatting that data. You can optimize that size, again, kind of 5 to 50 megabytes, somewhere in there. It's not one size fits all, but somewhere in there. And put it in S3 intelligent tiering. It was, again, built for this. So when we're talking that amount of data size, the per object management fee becomes very cost effective. It's very minimal. It removes the risk of the retrieval fee from you. So you have a very predictable bill that's automatically cost optimized. You can still let it be a data lake, let many users and applications access it. And then, it's going to depend on you, and this is where you use those tools like storage class analysis or use CloudWatch metrics and inventory reports and understand, okay, how is my data being accessed over time? And if it's important data, then it's no longer active. You've understood when it's active. It might be that 180-day example. Again, not one size fits all, but move that off to S3 Glacier and ultimately Glacier Deep Archive so that you have those data sets, that valuable data for later use, but you're not paying more money up front while you're not using it. I'm going to give 2 other examples. They're anonymous customer examples, but they also kind of speak to the use of different storage classes. So one of those is a pharmaceutical company that has a clinical trial application running on AWS. And so in this application, I'm going to focus more on the storage aspects of it in the interest of time, but in this application, they have multiple data sources coming in. So they have past patient data records, they have the data coming from the clinical trial itself, and they have data coming from public sources like clinicaltrials.gov. And all of these are coming into, again, that ingest layer. You can think of it very similar to the data lake sort of use case here. That's all coming in, and it's coming in and being stored in S3 standard, just all the raw data, differing sizes, not going to be long-lived, makes sense for S3 standard. They have because this is patient data, there is a regulatory requirement that they must keep a secondary copy of that data, all the ingest data, all the raw data. So to maximize their savings, they're replicating that data into a different region, into an S3 Glacier bucket. Keeping that, again, meeting their regulatory requirements, but they know they're not really going to access it, so they're taking advantage of cost savings. So then using Glue, they're performing an ETL process, formatting that data, optimizing for size, optimizing for their needs. They store that into S3 intelligent tiering. And then the formatted data, then they run another separate Glue process that's pulling out the patient featured data, I think is what they call it. And that is things like, do they meet this, have they had this condition, a certain condition in the past, or do they meet this indicator that they're trying to find in their study? And then that goes into a separate repository, also that is fairly well formatted data. So that is also stored in Amazon, in S3 intelligent tiering, which then can be accessed programmatically by users through their application. But so again, multiple storage classes in there for one workflow. The other one is a great one, is in the data protection space. So this is a AWS partner that has implemented their backups. So they have a data protection SaaS offering that has completely been built from the ground up on AWS, but touches a number of different use cases. So this company has enterprise class data protection. They have customers running their data protection agents on cloud-native applications that are running in EC2. They have them running on servers that are running in on-premises data centers. And they have them running on, they have client-based data protection running on people's laptops. So all this data is coming in, going through their upfront processing, and then is ultimately stored in S3 standard. And to keep that data, there's about 55 petabytes last I saw on this. And so they keep that in S3 standard for the first 90 days, and that's per the SLA that they have with their customers, and also sort of where they see the most restores come out of, right? So they're keeping the data active, they're not implementing a retrieval fee, because they know that in aggregate, they're gonna see quite a few restores coming out of this backup use case. And then after 90 days, they use a lifecycle policy, and they tier all that data down to Glacier. Still can be restored in minutes if their customers demand it, different levers the customer can pull. But then they also have a SLA with their customers that for disaster recovery, as data is being written, as all of those customers' backups are being written into S3 standard, they're replicating a copy into a different region into Glacier Deep Archive to meet that SLA and their sort of compliance requirement for being able to store their customers' data safely. So wrapping up, we covered quite a bit in here. So just a few reminders. So it starts with the application, it starts with the workload. You need to understand your application's requirements. Organize your data. Tags are very, very powerful to do this. Prefixes can not only help just with optimizing for performance, but also in understanding where your data lives and being able to set lifecycle policies and the like against those organizational structures. Take advantage of all the appropriate storage classes. And again, a good way to do that is with tags, right? You could go and tag data for the appropriate storage class that you might want to lifecycle it to. Use the building blocks that I talked about, like storage class analysis, S3 inventory reports, all AWS budgets, CloudWatch, to plan and monitor your spend. Use intelligent tiering if it fits your use case, right? If you're sort of in a standardized object size, then it can be a very, very powerful way of just going ahead and automating this. And then finally, if you have long-lived data that you need to retain over the long term, take a look at Glacier Deep Archive. It's tremendous savings, it's lowest cost cloud storage in the market. And then quick ad for AWS training and certification. There are a number if you want to learn more about these different storage services, the URL's down there. There's quite a bit of data you can go in, lots of free training available in there to learn more and get a little bit deeper on our storage classes. And with that, thank you very much for your time. Rui and I will stay around for a little bit. If any of you have questions, we can step out in the hall. I don't think there's any sessions after this, but I'm sure these guys want to go home. And so we'll stick around and answer any questions. Thanks.